So let's continue to speak a little bit about the test design techniques, and now let's consider the category or the type of white box techniques. These are structure-based techniques that are basically identified by reading the code, the lines of code that are produced inside a software system. So there are a couple of levels and a couple of examples that are presented here. You can achieve a structure design of testing when you're trying to reach for the component level, where you identify the structure of a software component such as a statement, a decision, a branch, or even distinct paths inside the code. You can then rise to the next level and consider the integration level and see the structure that you are trying to test as a call tree, and usually having something visual like a diagram helps to address all the modules that should be considered when trying to design a test case for integration. If we consider the last level inside of the development core test design, we are addressing the system level. And at that point, the structure can be a menu structure when you definitely already have a feature for testing. It could be a business process or a web page structure. So this last level is the outmost level, and usually it can be also addressed by a black box technique, because at this level you have the feature completely available to be executed by someone simply using the software. You don't have to go lower code and actually analyze the structure of the code to produce a test case at this level, but you can also do it. So yes, this implies some type of overlapping between this last level and a black box technique, but you can actually conduct a test case and define a test case using this example. There are 3 code-related structural techniques that include code coverage, and the techniques are based on statements, branches, and decisions. And when we are speaking about branches and decisions, we usually use a control flow diagram so that we can visualize the alternatives, the options for each decision. Let's take a look at statement testing and coverage. First, let's try to state what is a statement. So, according to ITSQB, a statement is an identity in a programming language, which is typically the smallest indivisible unit of execution. So it's a line of code that gets processed. Statement coverage is a metric, so it's the percentage of the executable statements that have been exercised by a suite of tests, a set of tests. Those are ISTQB definitions. When trying to conduct a statement testing technique, the idea is to derive test cases to execute specific statements in your lines of code. Normally, the idea is to increase statement coverage. Statement coverage, we can see it as the result of a formula where you get the number of executable statements that are covered by test cases divided by the number of all executable statements in the code under test. 100% statement coverage for a component is achieved by executing all of the executable statements in that component. Let's look at some example. Consider the following lines of code. So we have in pseudocode, we have an algorithm that actually implies the sequence of 3 lines of code. Those 3 lines of code are all executable statements. There isn't one decision, there isn't one branch, there isn't a repetition structure. So you can follow along these lines of code and actually know that one test is the smallest number of test cases that are required to execute all the 3 executable statements. So since there are no conditions, and once you run this small program, all the lines will be executed, a simple test, one single test, is enough to achieve the 100% statement coverage of this pseudocode. Looking at another example, for instance, another one that also has 3 lines of code, you can see that there is only one executable statement in here, that's the one present in line number 2, that displays an error message. The other 2 lines are lines of code, but the first one is a decision, and the last one is the end of the block that gets executed if the decision is assessed as true. Okay, so how many test cases will I need to achieve the 100% statement coverage that could be required? You need at least one test case, so this is the minimum number of test cases that would be required to execute line number 2. However, this has a small distinction from the previous example, because in here you have to account for the fact that the age of the test case is a relevant aspect. In here, in order to get the executable statement present at line 2 to be executed, you have to ensure that the age at this moment, at line number 1, is below 17. So it's lower than 17. It could be, for instance, age equals 15. And if age equals 15, this will be assessed as true. It's a true condition, and then the error message will be displayed.